When you see a pattern that's concrete, you try and express that pattern in abstract. Okay, right? So this here, what I'm about to write is the binomial theorem. This is the theorem of explaining all of these guys. These we defined at the very beginning as coefficients of this, right? And then somehow the rabbit hole took us to all this factorial business. Right? Now you see the point of Wednesday's lesson. Okay, let's begin this. Easy bits first. It's a fraction. It's a fraction. What's on the top? N factorial every single time. That's your building block. That's where you always start. On the denominator, I always seem to have two factorials, right? Two factorials that go together. One of them is fixing up this one, and then there's another one which is actually dividing, right? So I noticed some things that are very, structured about these denominators. For starters, the two factorials, what do they always add up to? 6. They always add up to 6, or should I say, n, right? So one of them, though, is this number. Can you see that? Look at this. Let's have a look at 6C4, right? 6C4. The 4 factorial is right there. See it? 6C3. The 3 factorial is there, etc. Right? So one of these factorials will be r factorial. Now, if I want these two to add together to be n, it's going to be n minus r factorial. Bam. That is the binomial theorem. Now, what's beautiful about this is, remember I posed all these questions to you about Pascal's triangle, like why? Well, when you get to something like this, it's not, oh man, new thing to memorize. It's watch how this makes sense of everything. Okay? Example. NC0. What is NC0? According to this definition, it's n factorial on 0 factorial n minus 0 factorial, right? Which is n factorial on 1 times n factorial, which better be 1. Let's try the other one. We said that NCN, right? What was that equal to? Well, let's just go to the definition. It's n factorial on, tell me. N factorial n minus n factorial, which is n factorial on n factorial 0 factorial, which is 1. 1. Let me give you another one. We said this whole triangle is symmetrical. And then we went to the effort of expressing that symmetry in terms of our NCR notation, right? I believe we said something like this. Didn't we? Right? If you look at it from one side, it's going to be equal to the same term on the same row from the other side, right? Well, let's have a good look at this. Let's just quickly prove this. Right-hand side. Okay, I won't need much room. That's n minus r. Okay, by definition. By definition, watch out here. Tell me the easy bit. What's on the numerator? N factorial. Okay, what's on the denominator?
Bracket n minus r.
I'm going to have this factorial. And then I'm going to have, watch, I've got a lot of different letters flying around and sometimes being reused, which is a bit tricky. It's going to be n minus that. Factorial.
Yeah.
Recognize it?
Yeah.
You recognize it? That was not by coincidence. Okay. What's that equal to? That's n factorial on n minus r factorial. N minus n.
0.
Negative minus negative r. Bam.